All right, last lesson of the unit. What is the altitude of this triangle? So when you hear the word altitude, I want you to think of height. So I know, like, you may have known the area formula for a triangle, which is base times height. You could also call it base times the altitude. So when we find the altitude, we really find the height of the triangle. So again, what you have to do to find the altitude is it's a perpendicular. So again, that means intersects at a 90-degree angle from a vertex to the opposite side. So if I were to draw this one up, I would say this would be somewhere around where my right angle would be. My right angle for this one would be about straight down. And then this one over here, I'd say my right angle is going to be about right there. So we could say, we could technically find the altitude from each side. And then this point right here is called the orthocenter. So we can use GeoGebra to help show this. So if I draw my triangle, and I'm going to draw an acute triangle, so all my angles are less than 90 degrees. I'm going to find a perpendicular line from my vertex over here, my vertex to the opposite side, and my vertex to the opposite side. So again, notice it's not necessarily in the middle. It's not a median like last lesson. Median is middle. Perpendicular means crosses at a 90-degree angle. And this creates point G, which is our orthocenter. Where is point? Or this would be point D. So this is for an acute triangle. Now, if I were to do this with an obtuse triangle, and again, you'll notice that, hey, my previous example was my orthocenter was inside of my triangle. Can't move it. Try again. If I have an obtuse triangle, my orthocenter is going to be, outside of my triangle. So you can see the orthocenter is actually all the way down here. So where does it cross? It crosses all the way down here to get to my orthocenter. So that's again for an obtuse triangle. And so if acute is inside and obtuse is outside, I bet you can guess that if we had a right triangle, and again, I'm not necessarily guaranteeing that that's a right triangle, but it's pretty close, that when I do the same exact thing, I'm gonna get a vertex that is basically on my line, or on my vertex. So my orthocenter for this case, you can see, is exactly the same as one of the vertexes of my triangle. And again, that is for a right triangle. So if I jump back to my notes, come on, there we go. To find the orthocenter of this triangle, again, this is an obtuse triangle, so my guess is that it is going to be on the outside. I'm going to say, let's see here, to find this 90-degree angle, I'm going to probably go about something like this. Now you have to pretend like this line extends out here, and it extends out here. Find this one, I'm going to have to go quite a ways. I'm going to have to go all the way out here to reach it. And then kind of the same idea for this one. I'm going to have to go all the way down here. Now again, I know that that's not super accurate. I was kind of demonstrating that, but GeoGebra works much better for that, where when we can try to draw one very similar to that. So we got again, I'm going to find a perpendicular line from the vertex to the outside, vertex to the, oops. Oh no, that's right. And then my vertex to this line. So I had it a little goofed up there. We can see that it intersects over here on the outside, where point D should be. There. So we'll have to redraw this one. Something like this, something like this, and then this one goes something like this. So make sure you have this written down in your notes. Again, this will help you study and prepare for your test. Your circumcenter uses perpendicular bisectors, and it's equidistant to the vertices. Again, this creates a circumscribed circle. The incenter uses angle bisectors, not perpendicular bisectors, and is equidistant to all the sides. So again, this would be like your inscribed circle. The centroid uses the medians, which splits the median into 2/3 and 1/3. So again, using what you know to figure out what you don't know. And the orthocenter uses the altitudes, and there's kind of a few kind of complex properties, but really we're just going to kind of call it the center of mass. So if you were to take an acute or a right triangle and you were to find the orthocenter and you cut out the triangle, you'd be able to balance it on your piece of pencil and spin it around. So if you want to try that, please by all means be my guest. Make sure you have this stuff written down in your notes.